Today's input has one pair of ranges on each line. For example, the range 2, 6 means 2, 3, 4, 5, 6, and the range 4, 8 means 4, 5, 6, 7, 8. And of course, we want to take this large string and turn it into a more digestible format that looks like this. So one vector per line where only the numbers are preserved. The dashes and commas don't really have meaning for us. Okay, and I use a reseek function for that. We use a regular expression that looks exactly like we expect, number dash number comma number dash number, and we enclose the numbers into parentheses because those are the regular expression groups that we're interested in. Okay, so what does this actually spit out? So for the very first line, 2, 4, 6, 8, it gives us a vector with the exact same line verbatim, which is not interesting to us. That's group 0. And then the groups 1, 2, 3, and 4 are the numbers that we're interested in as substrings from the original input. Okay, so maybe let's start out by destructuring these vectors into the interesting 4 groups. Let's do that like this. So that would be, well, the first group is not interesting for us. We use an underscore by convention. And then let's say A, B, X, and Y for the next 4 groups. And then we can, for example, put that back into a vector just to see if that works. And here we can see now only the interesting groups are preserved. And if we are interested in these 4 groups as one thing, one collection, one sequence anyway, we can use a shorter syntax. We can say after the first element, we want additional elements as one sequence. So that would be A, B, X, 1 as one thing. And then we can replace this handcrafted vector with just A, B, X, Y. And then we get the sequence 2, 4, 6, 8. And that's useful because now we can say, for example, map the parse long function over that. And then it should turn the sequence of strings into a sequence of integers, which you now don't see because the tests pass. Okay, and the map gives us a lazy sequence, which is not really useful here because if we look at the first number, then we're also going to look at the second, third, and fourth. So the parsing of those, it's not really useful to defer that until later. So we can use an eager version. The map v function is eager because it returns a vector. That's what the v in the name means. Okay, so then on to the next function. We want to know if a range fully contains the other. For example, 2, 8 fully contains 3, 7, and 4, 6 fully contains 6, 6. And graphically speaking, if x, y is contained in AB or AB is contained in xy. Right, so we can simply write that down. So those is a non-descending order basically. And for that we have this operator AXYB or XABY that passes the tests. And if, maybe you're surprised that we can pass more than 2 arguments. So this operator takes 1 argument, 2 arguments, or more than 2. And here you can see the same syntax again. So the first 2 operands would be A and X in our example, and the more would be a sequence containing Y and B. And then it's probably done via recursion or something. Yeah, here's the recursive case. Okay, so that works. And I think the comment is now not really useful because it exactly mirrors the code one-to-one. So let's get rid of that. Right, and then for the actual part 1, we have to now combine our functions. So first we take our input and then we call the range pairs function on that. And then we only want to keep those vectors, where the fully contains predicate says, yup, fully contains. So that would be a filter for fully contains. Okay, and then we have 2 of those vectors left, and 2 is the number that we expect. So we just have to count the remaining vectors, and then the tests pass. So that's quite trivial. Okay, next function. Now we're interested in the overlaps. Yeah, and I also did that graphically with a comment here for the opposite case. So I find non-overlapping easier to detect than overlapping. So when do they not overlap? When AB comes before XY or when XY comes before AB. And we can simply do that again, an OR of Now I say bx ya. I can't do it more. For example, it doesn't make sense to do it like this, because a isn't necessarily smaller than b, and x isn't necessarily smaller than y. So we are restricted to the middle cases here, and we already know that these are in the correct order relative to each other. It doesn't really have to be tested, but it would have been nice for readability. So maybe let's preserve the comments now. Let's put this guy here for the intention and this guy here. Okay. Let's see if the tests pass. Yeah, they pass. Cool. And then for part 2, what do? We call the range pairs function again on our input. And then, yeah, basically we want to filter for the opposite of separate. And there's already a standard library function. It's not called filter, it's called remove separate. So we want to remove the separate ranges. Then 4 of them are left, and 4 is exactly the number that we expect. So let's simply count them, and then we should be golden. Yeah, so the filter function you're probably already familiar with, a lazy sequence of the items for which the predicate returns true, quite a lot of code, and maybe you would expect remove to be a copy-paste of that with some reverse logic, but instead it's much easier. It simply delegates to filter by complementing the predicate, by reversing the predicate basically. And if you look how complement is implemented, complement takes a function such as separate in our case, and it returns a new function that when given an x, such as one of our 4-element vectors, it will call the original function separate and then simply negate the result.